Hello everyone, I'm very glad that I can have this chance to talk about my project here, which is Question About Questions, an empirical analysis of information need on Twitter. This is the joint work with my advisor, Zhe Zhao from School of Information. So in this talk, I will talk about this user asking question behavior in social network. I will first talk about what is this information need in Twitter, and then go through the motivations of this problem, talk about the challenges and the solution of both detecting and analyzing the information need. And after that, I will talk about the conclusion and some future directions. So what is information need? An informal and direct explanation is that the need to know something. And here is some of the information need in the formats of a question. So here in our work, we study the user seeking information behavior by asking questions on Twitter or under any other general social networks. So the motivation of this work lies in the following two questions. So what do people do when they have information need? And what can we do if we know people's information need? So based on the study and understanding the first question, we propose the first part of our work on detecting the information need, which includes a thorough understanding of this user behavior in social network and trying to define what are the traits that convey information need, and also includes a simple and straightforward classification algorithm that can automatically find information needs. And by studying the second question, we propose the second part of the work, which is an extensive analysis about the information need on a very large data set. So starting from the first question, what do people do when they have information need? So conventionally, they will just ask questions to anyone they know. And this is usually limited by the number of people one can possibly contact in real world. And thanks to the online services such as Google and Yahoo Answer, we can formulate our information needs, then try to search them online. But by using Google, we need to try to reorganize the information need into keywords, and it could be very hard to retrieve some very complicated information needs. And by using Yahoo Answer, we probably need to wait for a long time for someone to answer the question. And neither of the methods can ask something like social-related questions. So there are more and more people starting to ask questions on Facebook or Twitter. And I will show you my personal experience on asking questions in social media. And so 2 years ago, when I was not very familiar with the parking system, I really got a lot of parking tickets. So one day, as some of the graduate students do, I walked out the CSE building at 6:08 a.m. and found my car. There's a parking ticket on that, and this is like the fourth parking ticket I get in a week. So I got really annoyed and wondered if I can just leave my car there because I already have a parking ticket, so I don't need to worry about parking. We sound not very sure about that, and this is apparently not the question that I can the information I can find on Google. So I post a Facebook status, and maybe just after 20 minutes, my friend saying that it's not okay to do so because sometimes they will give you another parking ticket after 5 or 8 hours. This is really amazing because I can just get an answer like in 20 minutes in the very early morning and get very accurate results. So here also show some examples on Twitter that people asking various of information such as the extent of the Sigma conference, or whether there is a road work, very specific and usually cannot be found on Google or like in Yahoo Answer. So by asking questions in Twitter or any other related social media, we can see that we can ask questions for various of information, and we can usually get personalized information from our friends, and the friends are more likely to answer that because they probably know us, and even if they don't know the answer, they can broadcast the question maybe by retweet, or by share it, or even like it. However, there are also some problems in social network because Twitter, for example, is not designed for asking questions. So it's a general social network, which means there are a lot of information the information need. So for example, there are like 3,000 tweets per second, and one user can usually get one or two, several hundred tweets from one day. That means even if the user's friend posts the information need, and the user cannot see that right away after the post, he probably would miss it. So the solution is that there need to be an automatic mechanism to detect the information need so that we can locate the information need and provide to the user. The challenge of doing that is that for each trace, there are usually just limited content, and there are personal variance, and we need to deal with sarcasms or rhetorical questions that are very complicated patterns, and also we need to have very high accuracy with very efficient time. So here comes the first part of our work, which is the information need detector. Here shows the framework. The blue column is showing how we label how we do the process in labeling the data set, and the red column shows that how we use the label data set to train a classifier. So in the labeling process, we model our problem, the detection of information needs as a binary classification task. We provide this code book, which is a guidance for human annotators to label the data set. We have 2 human annotators to label 5,000 random sample tweets in 2011 September, and there are about 3,000 tweets that are English, and the 2 coders agree with each other. The inter-rater reliability measured by kappa score is 0.835, which is relatively high. So by using this label data set, we propose this information detector, which uses a very typical classification algorithm framework that we do feature extraction on multiple source of features. Then we do feature selection to trying to eliminate some noise. And after that, we learn classifiers on these different sorts of feature. And using something like a boosting method could be AdaBoost to merge the classifiers together. So we use the average accuracy of the tenfold cross-validation on the label data set. So here shows a tweet containing information need. That is, dear professors, will I pass the prelim? So I extract 4 source of features, that is an n-gram, from unigram to trigrams, and also I use the synsets and hypernyms from WordNet, and use the part of speech feature and model that into n-gram, and also the metadata, for example, like the number of words, number of hashtags, and anything else. So here shows the dimension, like 44,000 or several tens of thousand features we extract after the feature extraction. We directly train SVM on these raw features, and shows the accuracy here. We can see that accuracy could be something about like 70%. So on the next step, we show that how we use the feature selection method to try to improve this score. So we try several feature selection methods, for example, such as simply accuracy or information gain. And we see that this binomial separation is a really good approach for the feature selection in our task. So the intuition is that to try to obtain monitor 2 score, that is the true positive examples in all the examples containing the feature, and also the false positive examples in all the examples do not contain the feature. So the method trying to maximize this difference to select the features that have the best score. So here show the result. So in this table, we can see that after the feature selection, we can improve the binary classification task into the accuracy about 0.856, which is already very high. So in the next step, we are trying to merge these 4 different classifiers trained by n-gram, WordNet, part of speech, and metadata together. So we use SVM to train that, and to merge this classifier together, we are trying to use something related to something similar to AdaBoost, which is a very well used algorithm in the trying to merge weak learners to train a strong learner iteration by iteration. So, but here our problem is that since our classifier is also already about 0.8, it is already relatively high. So we need to train better classifiers from the good learners. So directly using AdaBoost is not very suitable. So we use this AdaBoost with the diversity constraint. Intuitively, we are going to select, try to merge classifiers based on the criterion of that it has a higher accuracy as well as higher diversity, which means the new classifier we added in the iteration can be likely to not agree with the classifiers we already have. So here shows the result of this tuning of the experiment. So instead of discussing with this figure, I will just show the direct final result I get. That is the accuracy using AdaBoost with diversity is 0.867. So to sum up here, that we first understand the labeling the tweets. The inter-rater reliability is 0.835, and we use the label data set to develop this classifier to detect all the tweets coming information need by doing feature selection using SVM and the AdaBoost method. So at this point, we have this classifier that we can find people's information need from Twitter. So we'll begin to discuss the next question, that what can we do if we know people's information need. So intuitively, if we know what people want to know in social media or in real world, we can develop a lot of very meaningful applications. For example, that we can discover the trend of people's need, or we can understand some burst events or predict trending topics. For example, if there are a lot of people asking what iPhone 6 will be like, or there are some new features in Google Glass, it's more likely that this kind of products will be really popular when they are being released. So in our analysis, our goal is to show that this information need is really powerful and have the potential power to do these applications. So we did a trend analysis, we do burst detection and entropy analysis, as well as the trend prediction to show this. So after developing this information need detector, we directly apply this classifier on a large data set of tweets. Then we retrieve a lot of tweets conveying information need and trying to do analysis on this. So the data set we use is the 10% tweets by the Garden House API from July 2011 to November 2011, which contain 1.63 billion tweets. So we extract around 51 million tweets that convey information need. So by using this large amount of tweets, we did the following analysis, that we first do the content analysis, and we found out that some trend and some burst event may be very interesting. Then we do burst event detection and entropy analysis to study what is the burst event. And after that, we do the trend prediction analysis to show that this information need actually has some predictive power in predicting the trend of other sources. For example, like the general discussion, which we call the background of the Twitter, as well as the search queries in Google. So first I will show you this general trend, which is the number of the tweets containing information need, plotted in the blue line, and the red dotted line is the background, that is the general discussion of Twitter. So from the time period, so which we can see they are highly correlated, but they're sharing some periodic features, but also there are some difference. So we will further dig into the difference between information need and background. So here shows the top frequent keyword in the information need as well as in the background. That we can see that the keywords in the background is very general, but in the information need, they're asking, for example, like recommendations and suggestions for some specific topics. And then we show some trend of information need as well as background containing several keywords. So the up figure shows the tweets containing the keyword Obama, and the bottom figure shows the tweets containing the keyword scandal. Also, the blue line is the information need, and the red line is the background. So actually, the spike or the burst event here is really meaningful. The arrow is usually corresponding to some real-world event. For example, the region here shows that Obama gave us some speech, and there are a lot of people discussing the speech during September 2011. And this kind of pattern is very interesting because there is a very huge spike in information need, but there is no spike or corresponding correlated patterns in the background. So we study this question asked here in the spike. This is about the Catholic Church scandal, and there are a lot of people asking how about this and what's going on here, but there is no clarification either from the news agent or from the general discussion, which shows that there is a huge gap between the information need and the background. So here shows the difference measured by and the correlation of different keywords in the two data sets, which we can see that just like 10% of the keywords in information need and background are highly correlated. So after showing the trend of information need based on different keywords, what we'll do next is to do a burst event detection that are trying to find all of the spike in the time series we have. So what we do is to do the burst event detection by using subsequence matching using Euclidean distance. So the query we use is like this pattern in dark blue line. So what we are going to do is find all the similar patterns in the database. That is the time series of information need and background in the 11,000 keywords. So the result here shows that there are 12,000 keywords. There are around 12,000 burst events in background, but there are 2,000 more burst events in the information need, which could indicate that this information need feature is really sensitive to like the burst event or real-world event. So here shows the distribution of all the burst events. The figure here shows the number of burst events during the time period, and we can see that during some time, the blue line, the information need, have much more burst events here. And here shows the distribution of the burst event measured by the keyword. So the x-axis is the time period, the y-axis is the different keyword. So if there is a straight line in this graph, it shows that there is a burst event. The blue line is the burst event in information need, the red line is the background, and the green line shows both. So to study what is the burst event, what we do next is this entropy analysis. So we use entropy calculated by this equation to trying to find what is the burst event. The intuition is that if there is a large portion of users want to discuss a major event, the entropy will drop. So we calculate the entropy of information need and background for every day and shows the figure here. So the blue line is still the entropy of information need, and red line is still the entropy of background. What we did is to use entropy to find the real-world event is to show that trying to find the entropy drop on this time series. So if there is entropy drop, we try to calculate the difference of the keyword in the day and the day before the entropy drop. So here shows some event. For example, in this entropy drop, there is an earthquake and the hurricane happens in the East Coast last year, 2011. There are a lot of users asking what's going on with their friends. Are they safe? And this part is actually very interesting because there is an entropy drop in the information need, but there is an entropy increase in the background. So we go through that. It shows that there is an iOS update which contains a bug. So everyone update the iOS by using the update. Their iPhone cannot work. So there are a lot of people asking that, but Apple didn't release a fix on that after 2 days. So actually so that means there are a lot of people want to know the stuff, but there is no answers for that. So at last, we do this predict power analysis that we are trying to show the predict power of the information need. So there already have some existing work show the Twitter have predict power in the news event, stock market, or even earthquake notice. So what we are doing is that to show that information need in Twitter can be indicated to predict the trend of other sources, for example, the background of Twitter, as well as the search engine query logs. So what the method we use is called Granger causality test, which is a statistical test, by trying to predict whether one time series has the predict power to the other using this linear regression model. So the data set we use, the three sources of time series, the Google trend, and the background and information need. So the data set we use is 60 keywords that extract from the hot searches in Google, top keywords in background of Twitter, and the top keywords in the information need. So I will just directly show the result. The result is measured by the number of keywords one source can be used to predict another. So in this graph, the x-axis is the significance level, the y-axis is the number of keywords one can be used to predict another. So the blue line is the number of keyword information need can be used to predict a Google trend, and the red line is the number of keyword background of Twitter can be used to predict a Google trend. And in this figure, the blue line is the same, but the red line is the number of keyword Google trend can be used to predict the information need. We can see that under a very high significance level, there are more than 45 keywords, that is roughly 75% of the keywords that information need can be used to predict the Google trend. So here shows the proportion of the keywords. So to sum up, we analyze millions of information need from billions of tweets. Our goal is to show the uniqueness of and the importance of this feature. So the summary of the analysis is that we confirm that the behavior of information seeking is substantially different from the background of Twitter. And the information need in Twitter are more sensitive to real-world events, and we use entropy analysis that can provide a good way to detect real-world events and the impact on the topics being discussed. And with the subset of keywords, we found that information need in Twitter has a predictive power of search queries in Google. So the conclusion of this work is that what we study is the user asking question behavior in social network. What we have done is a thorough understanding of what is this type of user behavior, and we propose this automatic information need detector, and we use that information detector to analyze large amount of information needs. So the result we have is the codebook, which is a guidance for human to label the tweets, and a high accuracy information need classifier. And evidence showing that this feature information need is very important and unique in Twitter. So some possible future directions include that first, we're trying to improve the IRR score, the inter-Twitter reliability, and try to improve the accuracy of the classifier. We're also trying to use the information need in some real-world applications such as rumor detection. And one other possible direction is that trying to fulfill the user's information need after locating that. So that's all the talk. Here shows some related work, and thank you.